The future of quantum computing. 9 powerful use cases. Some people estimate that as soon as the mid-2030s, quantum computers could become available to the mainstream public. This would enable us to perform activities that are considered impossible today. Here are 9 quantum computer use cases that could greatly impact our lives. 1. Faster and more effective artificial intelligence. Quantum computers will transform the field of artificial intelligence since they're able to process vast amounts of data at unparalleled speeds and simulate neural networks of enormous sizes. For certain types of problems, especially the ones that involve optimization, quantum computers can calculate all solutions to those problems simultaneously instead of calculating each solution sequential like classical computers would. Each of the solutions a quantum computer obtains could have a score associated with it. With all of this information up front, quantum computers can choose among all possible solutions and find the best answer significantly faster than a classical computer could. This could revolutionize machine learning and help us solve complex problems that were previously thought impossible. Additionally, quantum computing and artificial intelligence will continually reinforce each other and accelerate developments in both of those areas. Advances in deep learning will likely increase our understanding of quantum mechanics. While at the same time, fully realized quantum computers will likely surpass conventional computers in data pattern recognition and data classification. This could lead to virtual assistants that can detect emotions in your vocal patterns and adjust their tailored suggestions accordingly. And it could lead to non-playable video game characters that behave hyper-realistically and have the capability to carry nuanced conversations with you. According to McKinsey, we will likely start to see the benefits from this use case in the early 2030s. 2. Batteries for electric cars that are more energy efficient. Electric vehicle batteries contain battery cells that exert electric energy by charging and discharging. Quantum computing could provide improvements in the areas of cellular simulation and the aging of battery cells. These improvements could lead to faster charge times and electric vehicles that can drive considerably more miles between recharges. 3. Development of new drugs. When scientists need to develop new drugs and chemicals, they often need to examine the exact structure of a molecule to determine its properties and understand how it might interact with other molecules. Unfortunately, even relatively small molecules are extremely difficult to model accurately using classical computers, since each atom interacts in complex ways with other atoms. Currently, it's almost impossible for today's computers to simulate basic molecules that have relatively few atoms. Quantum computers are well suited to tackle this problem since the interaction of atoms within a molecule is itself a quantum system. In fact, experts believe that quantum computers will be able to model even the most complex molecules in our bodies. Every bit of progress in this direction will drive faster development of new drugs and other products, and potentially lead to transformative new cures. Using quantum computing, pharmaceutical companies could model larger and more complex molecules, better map interactions between a drug and its target patient, and reduce the time and costs of development processes. This could lead to better diagnostics, medications, and vaccines that come sooner and more efficiently to the market. And it could lead to the discovery of new drugs for serious diseases such as cancer, Alzheimer's, and heart disease. According to McKinsey, we could start to see the benefits from this use case by the mid-2020s. 4. Traffic optimization. Solving these problems with classical computing is a tedious, hit-and-miss process. The traveling salesman problem is an example of this type of problem. It aims to determine the shortest possible route between multiple cities, hitting each city once and returning to the starting point. This optimization problem is incredibly difficult for classical computers to handle. However, for a fully realized quantum computer, it's a cakewalk. Additionally, quantum computers could tackle routing challenges in real time by using live data from connected vehicles, containers and packages, roads and railways, warehouses, point-of-sale systems, and weather satellites. 5. The creation of new materials. IBM is using quantum computing to better understand the physical processes of nature, such as how matter behaves and interacts at the atomic and subatomic levels. This could lead to the creation of new materials for manufacturing. It could also help engineers design better plastics and computer chips. In the next couple of decades, quantum technology could help in the development of lighter and stronger materials for building automobiles, aircraft, and spacecraft. 6. Financial modeling. According to McKinsey, the financial industry has the potential to gain significant value from quantum computing by the mid-2030s. And Goldman Sachs recently announced that they could introduce quantum algorithms to price their financial instruments as soon as the mid-2020s. Quantum computing and financial modeling are a match made in heaven thanks to their structural similarities. The entire financial market can be modeled as a quantum process. In fact, a great deal of research has focused specifically on quantum computing's potential to dramatically speed up and improve the Monte Carlo model, which gauges the probability of various outcomes and their corresponding risks. Quantum computers have the potential to sample data differently by testing more outcomes with higher precision in a fraction of the time. Quantum computing could also speed activities related to portfolio optimization, customer targeting, prediction modeling, credit scoring, and fraud detection. 7. Cyber security. Since quantum computers can perform multiple calculations simultaneously, they have the potential to break any classical encryption system within the next 10 to 20 years. For example, it would take a classical computer 300 trillion years to break the 617 digits of the RSA 2048 standard for encryption. Based on our current trajectory, a fully working quantum computer in the 2030s could potentially achieve this in 10 seconds. They will be so effective at decryption that they could pose a national security risk to all developed nations. New quantum encryption technologies would be required to protect even our most basic online services. Scientists, as well as forward-thinking policymakers, are already working on quantum cryptography so that companies, governments, and citizens can protect their information. 8. Weather forecasting. Quantum computing's method of simultaneous, rather than sequential, calculation will likely be successful in analyzing the enormously complex system of variables that is the weather. 9. Manufacturing processes. Quantum computing can help companies streamline operations and manufacturing processes by solving supply chain optimization problems, such as determining the availability and pricing of manufacturing components without interrupting multifaceted supply chains. It can also take large manufacturing data sets and identify which parts of a complex manufacturing process contributed to operational failures. For products like microchips where this production process can have thousands of steps, quantum computing can have a significant impact.